Let's look at similar triangles. And remember from our lesson on similar figures that to be similar means that they have the same shape but a different size. And we categorize that with similar figures are figures with congruent angles and proportional sides. And we see that proportional side relationship when we look at the scale factor between two similar figures. So if all the angles are congruent and all the sides are proportional, then we would know that we had a pair of similar triangles. But what we want to look at is, let's just do the quickest of reviews. So this is a quick review. And remember that we had triangle congruency shortcuts or test. In order to tell if you had congruent triangles, you didn't have to know that all three pair of sides were congruent and all three pair of angles were congruent. We came up with 4 and possibly 5 tests. Our 4 tests were side, 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 angle, angle, side, angle, and angle, angle, side. And in a right triangle, we had hypotenuse, leg. But these were the 4 basic tests that would work regardless. So you might wonder if we also have shortcuts for our similar triangles. Do we have any shortcuts? And in fact, we do. Okay, so the similar triangle shortcuts are really the same as these, but it'll look different. I'm going to start with the fact that I created a pair of similar triangles just using the camera. I enlarged one so you can see that they look like they have the same shape, just a different size. And there could have been a dilation performed to produce an image from a pre-image in this case. But remember, anytime two figures have the same shape, it's always because the angles that are forming the shape are exactly the same every time you match up the pairs. The angles are congruent. So if you have a pair, if all the pairs of angles are congruent, that's going to guarantee that we have similar triangles. However, again, just kind of doing a little side work, if one triangle has angles, say, of 80 and 70, and another triangle has angles of 80 and 70, you might argue, well, what about the third angle? Well, we could do the math. That's 150. This would be 30, and the same thing here. Remember, we have a theorem that says if any two pair of angles are congruent between two triangles, then by default, the third pair has to be congruent since they add to 180. So what's the minimum it takes to guarantee that all the angles in the triangle will be equal? If you have two pair that are congruent, that's enough. And notice that angle side angle has two pair of angles, and so does angle angle side. So these two congruency tests, when it comes to similarity tests, they consolidate. And if you want to test for triangle similarity, if you know that you have two pair of angles congruent in a pair of triangles, that's enough to say that they're congruent. And remember that the symbol for similarity, unlike congruence, it's the congruent symbol without the equal sign underneath it. So it's just the tilde there. Okay, so angle is going to guarantee similarity. So that takes care of these two tests, and then the remaining two show up as well. I just want to show you what they look like. So side angle side would look like this. Going back to the same triangles I had before, Let's just start with this angle here in the bottom. You can see that those are congruent to one another. So if I know that those two angles are congruent, and then I know, say, that these two sides are proportional, I'm just going to quickly show you what that means, but then I'll just make up some numbers. So look, if I want to mark off how many times the small triangle, this side fits on the large, I've got once, twice, 3 times, and then some more. So it looks like maybe what, 3 1/4 possibly, something like that. Let's see what happens down here on the bottom side. Again, this isn't highly scientific and technical, but it fits once, twice, 3 times, and then not quite a whole again. So again, a portion of what was left. That number really should have been exactly the same for both of the sides, because that's the thing that's remaining steady and constant. So, but what it would look like would be something like this. Suppose I knew that this side was 8, and let's say that this side was 28. And let's say that this side is 10 and this side was 35. Would that guarantee proportionality and similar triangles? Well, as long as we have a scale factor, then that would be good to go. So remember to test to see if there's a scale factor. I'll do big over small as I set them up using the concept of proportionality. So the big side, this side here is 28, the small side is 8, and the larger triangle, the big side is 35 and the small side is 10. Let's take cross products and see if those products are the same. Well, we know this one's going to give us 280, 28 times 10, and then 35 times 8 on the other diagonal also gives us 280. So I can see that those sides are proportional. And if I want to come up, say, with an actual scale factor, then we can take a value from, it depends which way we're going, I suppose. Say if I was going from small to large, I know I want that scale factor to be greater than 1. So we could do the larger number over its matching smaller number, and 28 divided by 8, we have a scale factor of 3.5. So the sides in the big are 3.5 times larger. As long as you have a pair of corresponding sides and another pair of corresponding sides where that matches and the angle included between them is congruent, that's enough to guarantee that we are indeed working with similar triangles. So that's going to be side, angle, side. Okay, so it's a pair of proportional sides and the angle between them. And then side, side, side would be if you simply tested the triangles. So let's just draw a quick illustration, tested all 3 pair of sides. Let's just draw a quick illustration of what this looks like. So in angle, angle, you would be good to go if you knew that those angles were congruent and those sides and those angles were congruent. That's enough. That would guarantee that those triangles were similar to one another. Side, angle, side, let's stick with some easy numbers. Let's do 5 and 10. And then in this triangle, let's say this side is 10 and 20. So I definitely have a pair of proportional sides because there's a scale factor. If I go in this direction, k is equal to 2. 5 times 2 gives me 10, 10 times 2 gives me 20. So those pairs of sides are proportional and the angle that falls between them is congruent. And then side, side, side would look more like if we had 4, 6, and we'll go with 9. And then we have a bigger triangle where, let's just go ahead. We're going to keep this really simple for illustration points. Let's make our scale factor 3. So if this were 12, 18, and 27, okay? As long as all 3 pair of sides are proportional, I could set up my proportion, or I could identify a scale factor. I don't have to know anything about the angles. That's what side, side, side would look like. So we could test them, and we could do 4 over 12. Is it equal to 6 over 18? And is that also equal to 9 over 27? And if the answer there is yes, then there you go. Those would be similar by side, side, side.